I made some changes to hopefully improve the quality of the recordings. I realized there were some settings that I changed back in the winter that I forgot to change back, and that should help with just better quality recordings. The video quality will likely be better. I can't guarantee the audio. I'm still trying to figure out why it's so cranky, but hopefully I'll get something figured out. All right. So raise your hand if you had a lab yesterday. So everyone who had lab yesterday, you got a bit of a sneak peek about what we're going to be doing, and you were totally at a disadvantage for doing the lab because I never really introduced variables. So for those of you that have lab today, you're in luck. You'll be ahead of the curve. But that won't really matter going forward. Once we kind of get on pace, I think everything will be good. So yeah, we'll talk about variables. All right, so it's a very important concept that we're going to make heavy use of. You're going to be using variables a lot. So, now yeah, if you're going to pay attention once, now's the time. Variables store information in a named spot. That's it. That's all it is. But there is a bit of a catch. We use the equal sign in Python and many other similar languages to mean assignment. When I say right here in this example, a equals 5, which I'll just do right here, a equals 5, and then print a, what would we expect to happen? Well, give it a second, and it will print out 5 eventually. It's an assignment. It says, okay, take the value 5. 5 is a literal, right? It's the written number, 5. And store that value in the variable labeled a. That's it. So what I like to do is I like to think of, well, imagine I came along and made a box in my computer, called it A, and I'm going to put the value in it, and what did I say? A is 5. Okay, perfect. Put the 5 in there. Great. So the equals is an assignment. It means like, okay, set this. And there is an order to this. The stuff on the right-hand side of the assignment is the stuff that gets calculated. Put your mask on, bud. The other side is what you're assigning to. All right? That's how it works. It's common to mix those up, and that's normal for the first bit, but you'll get used to it. The left-hand side is where you're putting it. The right-hand side is the value that's being put into the variable. The reason I'm emphasizing equals as assignment is, now, a bunch of people here are going to say, okay, cool, makes sense. But if I were to say something like this, a equals a times 5, nope, a times 5, right? If I say that, what must the value of a be if we're thinking traditional algebra? 0, in traditional algebra sense. Because typically in math, we think of the equal sign as a statement of fact. It's saying these two things are equal, and that statement will be either true or false, and in this case, if a is 0, that's a true statement, right? So that statement can only be true if a is 0, right? Otherwise, it doesn't really make sense from a math side, right? Like if it's 1, that would say 1 equals 1 times 5. That doesn't make any sense, right? That's not how it works in Python. It's an assignment. We can check equality, and we will talk about that a little bit later, very soon. But we do that with 2 equal signs. So if I were to say this, and if the a has the value 5, I mean, that statement doesn't really make any sense at all. So what this really means is, let's follow this. The first line says a equals 5. So here's what we do. We take the value 5, we create a variable, a box, and with the label a. We can call the boxes almost anything we want. I just called it a for simplicity. I could call it a good. I can call it this if I want. There. And it'll still operate just the same. So I take the value 5, put in a box labeled a. right? Because we do the right-hand side. Take the value 5, and we calculate everything on the right-hand side. In this case, it's fairly straightforward. It's just the literal value 5. So take the value 5 and put it in the variable called a good variable name. Then, let me just make sure I'm recording. I do have a bad habit of that. Okay, good. Then what am I saying? Well, we always look at the right-hand side first. So I look and I say, okay, well, a good variable name. What value does a good variable name currently have? 5. Everyone say it with me. It's 5. Why? It literally says that above. That's it. So what happens if I take the value, a good variable name, which is 5, and I multiply it by 5? What do I get? Everybody yell it. 25. Why? Well, 5 times 5 is 25. And then where do I put that 25? Back in the box. So this becomes, I take the 5 out. I realize I could leave it, but for the sake of demonstration, I take the 5 out, and then I put 25 back in. What happened to the 5, though? Well, no, the value 5, a good variable name got assigned a new value, but the value 5 that was in the box, what happened to it? Yes, but it got overwritten. There was a 5 in this box, and every statement said was correct so far, really, but what I was going for is the value 5 that was in this box got overwritten, so that 5 is gone. And that's okay, because I don't care about it. If I wanted something else, there. Take a look at this and see if you can kind of figure out what's different about it. Yeah. So all it is, okay, I've got a variable called a good variable name. It's got the value 5. Then I take a good variable name, which is 5, multiply by 5, that's 25, and I put it in a different variable called another variable name. For the sake of simplicity, I'm just going to do this to make it more obvious. Nope. There. So if I run this, A will still be 5, B will be 25. Cool? But remember, equals is an assignment, not a statement of fact. And we can use variables to store a variety of different types. So C equals hello world. What do you think will happen when I run this program? It'll print out whatever value the variable C has, which is, of course, what everyone said, the string hello world. Cool. Yeah, we're stuck with equals. So in math, yeah, okay, whatever. In Python, we write that. I already ranted about that. Cool. For the sake of fun, okay, I'm going to give you a hint before I hit run. Some of this you might find this obvious, some of this you might not, and that's fine. The program runs sequentially. It's not, remember, equals is an assignment. It doesn't mean inequality, you know, if you're doing the math, you want everything to be consistent. Here, it's like step by step by step. You got a question? Yeah, well, I just want everyone to think about it. Raise your hand if you think you know what it is. Really high, let's do a poll. Good, that's good. It's fine if you don't, though. But let's work through it. The first line of code says what? Take the value 5, put it in the variable A. So A is a variable, and if I go look at that variable, what value does it have? 5. And then, so if I print out A, what should I see? Cool. And then the next line of code comes down, and it says A equals A times 5. So 5 times 5 is 25, and we put that back in A. So now what value does A have? Meaning that if I print out A again, what should I see? 5 and 25. There's 2 print statements, so that's why we've got the 2. I saw a question over there. Cool, cool. Okay, what can you do with a variable? A lot. I don't know. I could calculate this. I'm not gonna. Apparently the answer to that funny stuff I was doing was 1900. So what did I do is, well, I created a new variable b, and inside of it I put whatever a was times 77. Then I took b and subtracted a from it, and that's what, I guess, 1900. 1900 is the result. You can use variables in place of an expression. I mean, think of it like your math, right? If I said, like, print, imagine I had the function f of x equals, think math, okay? And by the way, what this is, the line of code starting with this, like, hashtag, or number sign, or pound sign, or octothorpe, there's a variety of different names for it. But the hash sign, it's like where I would write English words to myself or another programmer just to, like, keep notes. The computer, like Python, ignores line 1 entirely here because it's just a comment. But if I had f of x equals x plus 1, right? So just count or something. If I said, here, x equals 1. So if I said print out x plus 1, right, which is like this, right? And I hit run, I see 2. I can make this 10. Now I'll see whatever x is plus 1. Make it that number. That's it. Any questions so far about variables? I'm only scratching the surface so far, but now that you get a sense of what they are, questions. So we're all okay. All right. If I say that and your hand is up, just wave it, just in case I miss you. All right. So here, yeah, let's look at this code. A equals 5. B equals 7. A plus B is, well, 5 plus 7, which is 12. B equals 5. A plus B is now 10. Why? This, of course, assumes that A still exists, which is 5. But we overwrote B to not be 7. It's 5 now. Make sense? Let's write this out, actually. A equals 5. B equals 7. Print A plus... Whoop. Also, by the way, in the course notes, if you ever see these little arrows, just ignore them. You don't type them or anything. I'll explain what that means later in the course. And then, okay, wait, perfect. Print A, B, and then B equals 5, B, A plus B. All right, when I hit run, I want everyone to take a moment, look at this code, and think about what it should be printed out. There will be a total of 1, 2, 3, 4, 5 lines of output. What will each one of those be? Just come to an idea in your head. I'll give you 15 seconds. All right. Raise your hand if you think you know the answer. Cool. So let's think about it. A is 5, I print out A. We should see? B is 7, print out B. Then what? Print out the sum of the two values, which is 5 and 7. So that should be? Then B becomes 5. Print out B. Print out A plus B now. 5, 7, 12, 5, 10. Raise your hand if you were right. Wonderful. Anyone brave enough to say if they got it wrong? Sometimes it's good to find out, and then you get a sense of where you went wrong which could be good for everybody. Also, if you're ever afraid to ask a question, like it's a cliche where you're like, well, I don't want to ask this question because everyone else seems to get it. Almost always, at least half the class is thinking the exact same thing. So do your peers a favor and just ask the question, by the way. Yeah?
Do we need to put a space between, or like we have a variable?
Like this?
With the equal sign and the value or an operation?
Like this and this, you mean? Whoop.
Yeah.
So it'll still work, but the convention that we follow when programming in Python is you have those spaces. It's convention. Etiquette, whatever you want to call it. I don't know who said etiquette, but that's an interesting way to put it, yeah. There are a bunch of other conventions we'll learn as we go. There are rules you don't have to follow, but we all follow just to be good people. Like, I don't have to stop at the stop sign, but I do, right? All right. So, all right, I've been talking for a while. Do this little quick thing here. Do this activity. Assign various values and types, strings, integers, and floats to variables. Then add them together. What happens? Try adding variables of different type. Try that assign. Just do that. Do those 1, 2, 3, 4, 5 things. I'll give you 3 minutes to do it. I will say that, especially at this stage, the best way to learn is to just dick around with, just see what happens. Just try stuff. Explore. See if you can break it. See if you can't break it. See what you can do, what you can't do. Always just try. In fact, it's usually a good habit of a programmer to try to break stuff. Like, if you understand the system and how it works, and you think like, well, what if I do this? As terrible as that sounds, but we're kind of jerks. Yeah. So it's kind of hard to hear.
Oh, sorry. Am I supposed to be able to add integers and floats?
Yeah.
I thought yesterday you said that wasn't supposed to happen.
With some types, it won't work because they're both numbers, so that's why it's happy. But if you just say like 1 plus hello world,
I tried to do that,
and then it was like what? It probably said undefined operation for string and integer, right? Yeah. I saw a hand over here. Yeah. Try it and tell me what happens. Yeah.
Is there any etiquette in how you're supposed to write? Is there, like, for example, when you write the code and it says run, it's just accept it in the column, for example. And when we write it down, because we can't use equal signs, but it means something. Is there a way to put the signal on?
If you were writing it would be typical that if you were writing it down and it was a program you were writing, whether it was explicitly Python or what we would call pseudocode, which is somewhere between actual code and English. If you use the equal sign, people will know what that means. They'll be like, that's an assignment, right? Like this is a program, not a bunch of statements of equality. But good question though, because that's a good one. Yeah. What happened when you did it? You got in there? But what happens, try real quick, well here, I'll show you. So A equals 5, B equals 5.5, and C equals, hello, okay? Let's say A plus B, okay, that's reasonable, right? A plus C, no, you know what, I'm gonna do C plus A. So I want hello 1. Can only concatenate strings, not ints to strings. But there's a trick. Remember, so here. Whoop. Oh, right. I'm just going to comment this out temporarily. There. So, it's a 1, right? And it's an integer. But remember how, like, the number 1 is just a symbol, and we could have strings of symbols, right? So I could have the string 1. Would you agree? Why not, right? I could do this. Just for the sake of showing you, I'll make the string 5. There. It's a string, though. It's a 5, but it doesn't have the value 5. It's just the symbol 5, which to you and me means 5 in whatever context, but it's not an integer. So if I run this now, it works. I can concatenate the string with the integer if that integer is a string. So it's not actually an integer. It's just a symbol of the integer, but it's the string. Now, for those of you in the lab yesterday, you'll have remembered, we did it the other way. I don't want this, though. I really don't. I want to be able to concatenate the C in the variable A, and the variable A holds the integer 5. And I really want to concatenate those things. Well, there's a trick. I could tell Python, okay, you know that integer 5? Just turn it into a string. Here, I'll make it a little bit more explicit. D equals str of A, D, and then print type of A, and print D. So, A is 5, the integer 5. D, however, is I told Python, okay, that value A, which is 5, turn it into a string. Just do it. So Python was like, all right. So now it's the symbol 5. It's a string. And I showed you, right? I printed out the type of D, which it says class str. A is still an integer. It left A alone. Okay, so it left A unchanged. It didn't have a side effect on A. But it took the value from A, converted it to a string, and then I stored it in the variable D. And now I can concatenate those things. Similarly, if I say DE equals int of D, nope, E. If you're really, really, really getting it so far, try to see if you, like, what would the type be of E? It's fine if you, like, raise your hand if you think you know. Couple of people, it's entirely fine that you don't because I'm throwing a lot of weird new stuff at you. But what happens? Well, if stir of A turned whatever value A had into, if stir of A turned whatever value A had, A was an integer, into a string, what do you think int of a string would do? Turn it into an integer? Well, let's see. Yep, he's an integer. So I turned it from a string to an integer, no, an integer to a string back to an integer. Why? Because I could. Seems kind of silly, right? Like, well, why would you do that? Yeah, you're right, I don't know. I was just showing you, but you can do it. And of course, if you try to do this, can't assign to a literal. Yes?
So if I have like words I want to add together, and then I put them together, how do I assign that a new name?
A new variable?
Yeah.
Just like every other variable. So if I say A equals hello, B equals world, C equals A plus B, just as this. There's no trick to it. Is that the question you were asking?
Yeah, but I tried that, but I put like parentheses A plus B equals X. Will that not work? It's backwards.
Yeah, it's backwards.
Okay.
And that's the common early error, is getting them flipped. Yeah? And have a space between it? There are a couple of ways we can do it. One, probably the easiest kind of cheating way is this. Right? But an alternative is print will actually work. Like if I did A comma B, it would add. So the comma is like print these two things out on the same line. But let me ask you something. I'm gonna put you on the spot because you asked. And one thing you will find in computer programming is there's no trick other than what are the rules. If you know what the base level rules are and you just follow them, when in doubt, rely on those, and if you take your time, you'll find the answer. So, A is a string. B is a string. Okay? And I said A plus B, if you add two strings together, it concatenates them. Could I, what would I, and I want to figure out how to ask this question in a way that doesn't give it away, but is helpful enough that you could get the answer. If I told you there's a way by concatenating just another string to that series of concatenation, what would it be? Do you have any idea? No? I'll give you a hint. And by hint, I'll just show you. So here's what I did. Is I said, oh, I guess I have to print out C in order for you to see that it works. There. So here's what I did. Is I took the variable A that said hello. I concatenated it with the literal string space. I mean, I could do this if I want. And that's what we get. But it takes that as the literal. So we can add variables in literals. Do you see what I mean? Is how like the basic rules are the same. You can add a variable and a literal. Now, if this is still weirding you out about using literals and variables together with the strings, one, get used to it. But I mean, I could have assigned it a variable too. I could have made this. Yeah. Great question. Yeah.
So if there's like a bunch of different ways to do it, is there like a specific way you want to do it?
For now, probably the best way is the concatenation. There are arguably better ways, but it's going to depend on what you're doing. And we'll learn about more ways later, but for simplicity, the concatenation works pretty well. But it's going to depend on the context. Yeah. And I thought I saw a hand over here. I saw yours, but I thought, was your hand up? No? I thought I saw a hand over there. All right, what's up?
So you can turn the integer 5 into a string, and I tried and it didn't work, but is there a way for me to turn string hello
No, you can't for the same reason you can't. What is the integer version of the word hello? That's kind of a funny question, and there are multiple ways you could answer it, I suppose, but I don't know. So Python's like, I don't know. Now, we could write a way to convert it to an integer as defined as however we want, which we could learn about a little bit later in the course. But yeah, converting will only make sense if it can convert the stuff. By the way, fantastic that you tried it. That's the way to learn this stuff is, well, if I can convert the string 5 to an integer, can I convert the string hello to an integer? Try it. It didn't work. That right there, that question and just asking Python if it'll work is a great way to learn this stuff. Now, and I showed this to the lab yesterday. What's going to be printed out when I hit run? Someone yell it. Who said, raise your hand if you think it's 3. Someone said 3. Raise your hand if you think it's 12. Raise your hand if you think it's the symbols 1 and 2 in a string. Okay, that was me being kind of a jerk. But yeah, it looks like 12. Right? Why? Because we are not adding integers. We are adding strings. And what happens when you add strings? You concatenate them. Yeah. All right. Now for actual stuff. Okay, choosing a variable name. Using A, B, C, terrible. Never do that. Never do that. Always make your variable names as descriptive as possible. If you were calculating density, don't call it D, call it density. The convention we follow in Python is called like snake case or something. Other programming languages have different like default conventions that you follow. Some's called like camel case. But with this, what we do is we just separate words by underscores, right? You saw me do that earlier, like A underscore good underscore variable underscore name, right? They don't need to be multi-word, just make them make sense for what they're doing. It's always good. And a good reason for this is if I look at, I don't know, D equals, now this is not going to make sense at this stage, I guess, but when your variable names are descriptive, if you show me your code, if I just see it full of like A equals B and then A is D equals whatever, and then it's all these numbers together. But if I see like density equals, what's the equation for density? Mass divided by volume? I don't know. I made that up. Someone's got to know.
It's mass divided by volume, yes.
Awesome. That makes sense, right? How much mass there is and how much space is density. Perfect. So if you said D equals M divided by V, if you have no context of where you're coming from, I'm going to look at this and be like, what the hell is that? Right? But if you say, if your variable is vol, not spelt right, whatever, I immediately know what you're doing. Oh, density, it's the calculation, perfect. So good variable names help make your code readable. Another common thing is people, especially when they're just trying to get into programming, is you think, if I can do something in less lines of code, that's better, it's more efficient. No. We will talk a little bit about what it means for a program to be like efficient and what makes one algorithm to solve a problem A better than another algorithm to solve the same problem A. We will talk about those things, but lines of code won't really matter. In fact, there's an argument to be made about having verbose code, because verbose code is readable. I saw a joke on the internet. Sorry, I didn't have enough time to make my code simpler or something, right? It's hard, like it's not easy to do, but we like the simple, verbose, simple. If I can look at it, you almost want to be able to give it to your grandma who's never looked at a program before, and them to be like, okay, I can kind of figure what you're doing, because it's kind of like human readable. If your grandma knows how to code, then pick someone else in your family that doesn't. All right, suppose you're a fan of 80s arena rock. Create two variables. Here's a really quick activity. Create two variables called def and another one called leopard and set them to 19 and 87 respectively and add them together. Do it, quick. What's up?
Will we have planes taken off for not putting in spaces?
Uh,
I feel like I'm not doing that.
you could in theory, because the TAs will mark it and they got some flexibility as long as they're consistent. I wouldn't just follow conventions, play it safe. Yeah.
You only use def as a variable.
Why? What does it say?
There's like a index to my run. I think it's like a function.
Def is a special thing in Python. DEF means something. So because it's a reserved word that already has meaning, you can't use it as a variable name. There are restrictions on what we can use, what we can have in variable names. Variable names, for example, cannot be reserved words. Variable names cannot start with they have to start with like a letter. There are some constraints. Chances are you won't really bump into them, but there are some constraints. One of them is def because that is a reserved word. Now, a little bit on constants. So, unlike other programming languages where constants, I mean, they're still a thing in Python, but where I guess the programming language enforces them, slightly different. I'm explaining this poorly, but it doesn't matter too much. If we ever want to have a constant, so we have variables and the values inside those variables can change a little bit, right? But let's say hypothetically, I want to calculate sales tax, right? And I've got 1,000 lines of code, it's very important, and I'm calculating the grocery bill of people, and then, I want to calculate the sales tax in a variety of places throughout this code. It's a bajillion lines long. I know I said it's a million, it's a bajillion, whatever. It's very big. And I write the code as, well, everywhere I say times 1.15, right? Like I want to get what the total is with sales tax. Then the government comes along and says, all right, sales tax is now 12%. All right, so now I got to go into my code and change all those 1.15s. Maybe find and replace is pretty good, but maybe 1.15 exists somewhere else and I end up messing stuff up, whatever. What we could do instead is assign a constant. It's just a variable. But the intention behind the constant is it's set once at the beginning somewhere and it doesn't change throughout the course of the program. I, as the programmer, can go and change it later, right? If I take this right here, right? It's all good. But then I can come along later and change it to this, and that's fine. But the point is, it doesn't, the program itself won't change the value. What I mean by that is, I would never say something like this. Because the program itself modified the value. Only I'm allowed to change the value. And the convention for constants is all uppercase letters. And then that tells other programmers, if you give me your code with a constant in it and I see this variable with all uppercase letters, that tells me, oh, here's a variable, it's intended never to change. And the benefit of this is, if I've got that a bajillion lines of code that's calculating tax everywhere, I could just go to the top of that file and change, the top of my program and change sales tax to 1.12, not replacing the 1.15. So we use that for a couple of reasons. One, it might make your life easier if something comes along and changes. Two, you have no context. Sure, some bill might give you a hint, but maybe they also used a bad variable name called A. And if you say A equals 10.45 times 1.15, if you gave me that code, I'm going to have no idea what you're doing. And that might be fine, but I will have no idea what that means. If I see this though, 10.45 times sales tax, I go, oh, they're calculating sales tax, right? So there's a very good use of constant. Yeah. Oh, you were just, okay. Now, it's a convention in Python. The convention is you set it and you leave it alone in the code, like the code leaves it alone. But I can modify it, right? Oh, some bill. I should print out sales tax. See, sales tax is not 1.12 anymore. I can modify it, but now I'm breaking the convention. Don't do this. Don't break the convention. Follow the convention. Interestingly, in other programming languages, there's actually a way to make your constants very much constants that if the program tries to change it somewhere in the code, like in a language like Java, it'll say, no, you said that was a constant. Python will let you, but just follow the convention, because all the programmers that have come before you have all agreed, these are the rules, this is all the conventions we're following, and sorry, you gotta follow them too, like it or not. Yes? Because this is running as like an interpreter. All right, this is a complex question whether you realize it or not. So if I was running this as like I'm going to simplify a lot in this explanation as well for no other reason than just to save time, okay? If I'm using a language like Java or C++ or something, which they're similar languages to Python in terms of syntax, but when I write that code, what happens is I write that code, I'm going to talk about C++, it's simpler. I write that code, I compile it, because the code itself isn't what your computer can run, right? Your computer, the processor on your computer doesn't care that you said sales tax equals 1.15. What it wants is low voltages and high voltages to run through all the transistors and make all the calculations. So we compile it into zeros and ones. Then those zeros and ones, those encodings for low voltages and high voltages, run through the processor. Every time you hit run in that program, so you have your code, then once it's compiled, you have your program that you run. Like you double click, you create an exe and you run it. And then it runs, right? The running and like the coding are very separated. In Python, it's an interpreted language. There's a lot of similarities, but the difference here is I hit run. I'm gonna make this as explicit as possible, okay? Equals 77777, print. There we go. We see that, right? So now here's the problem. Right? You're like, well, hold on. Like, QWERTYUIO doesn't exist. It's because you are seeing this like front end. This code is still like running in the back. So even though I deleted it, QWERT whatever, it still knows that, well, like last time, like I've got that variable still, and its value is 77777. So when I say print it, even though it's not here written in the code, it's still remembered by like the interpreter. If you're like, that's scary, I agree. Because then you might end up deleting something and the value is not what you expect it to be, and then it's a whole nightmare. what you can do is, how do I do this again? Connect, view, manage, runtime, restart runtime. When you restart the runtime, it'll like, okay, obliterate everything, start fresh. So now if I hit run, we see there's no such thing. That was relatively complex. If you took anything away from this, cool. If not, whatever, doesn't matter. Convention, okay, and input. Sadly, we won't get to this, but everyone who has lab with me today, you'll see it. I'll see you all later.